we will be looking at orbital diagrams now to show how the dative covalent bond occurs during a Lewis acid Lewis base reaction. So let's consider the reaction between BF3 and ammonia, where ammonia has the lone pair of electrons and BF3 is going to act as a Lewis acid and is going to accept this lone pair of electron over here. So boron has 5 electrons. So we're going to fill up the 5 electrons in the orbitals. So 1, 2, 3, 4, and 5. Now this is in the ground state. Now boron is forming 3 bonds, 3 covalent bonds with fluorine. So we will need 3 unpaired electrons. So boron is going to move in an excited state to be able to form BF3. So we'll have 1 electron from the 2s orbital that is going to move into the 2p orbital, so that I end up here with 3 unpaired electrons. And because you have the 2s and the 2p, that is forming a new hybrid orbital. So we have an sp2 hybrid here. So sp2 hybrid BF3 is trigonal planar. And also BF3 here has a vacant 2pz orbital, and this empty orbital can accept 1 pair of electron. So we can accept 1 pair of electron, and this pair of electron, this is actually the lone pair of electron from NH3 that can be accepted. So we have the possibility of forming a coordinate bond with the empty 2pz orbital. So here the ammonia is going to donate a lone pair of electron to form a dative covalent bond with the BF3. It is able to do this because the BF3 has an empty 2pz orbital that can accept a pair of electron. So this process is explained here in words. You can take this down in your notes. So normally any particle that has vacant orbitals, empty orbitals, will be able to accept a lone pair of electrons. So they can have the possibility of acting as Lewis acids. And Lewis bases, if they have lone pair of electrons, they have the possibility of donating this lone pair of electrons. So they will be, so particles with lone pair of electrons act as Lewis bases. Now, transition metal elements have partially occupied D subshell. If you still remember what is a transition element, so they have an incompletely filled D subshell, so that they can form complex ions with ligands. So the ligands will be providing the lone pair, so the ligands will be acting as the Lewis bases, while the transition metal element, which have the empty D subshell, will be acting as the Lewis acid. So one example, cobalt plus water. So you will have the complex ion that will form with the ligand. So you have here copper, which is forming bonds with 6 ligands, so 6 dative bonds here. So this is going to be an octahedral complex, and here as well you have an octahedral complex, nickel forming bonds with 6 ligands. So copper Cu2 plus is acting as the Lewis acid, H2O ligand is acting as the Lewis base. So again, Lewis acid is nickel and ammonia is the